These are the notes for day 2 for lines of best fit. Okay, we actually covered this part in class. We talked about a residual plot, which gives us a closer pattern of the residuals, which is the difference between the points and the actual line. And we found out if there is a pattern, a linear fit's probably not very good. If there's not a pattern, something kind of crazy, then the dots in the real world probably fit a good line. Okay? So we got up to here, and in class we went ahead and plotted these points, found the line of best fit. Then we took every x, we just wrote down the x's and the y's, and then the y hat. And the y hat comes from plugging in each x into the line of best fit. You can do it on your calculator, or you can do it by hand. Okay, and then we found this is our residual, and it's the difference between the y value and the y hat value. Okay, and we found those by hand. And then what we need is the residual plot, and that is graphing the x's and this difference. So for example, very first point, at x is 1, my residual was negative 6.79, so it's right there. And I went ahead and graphed them all. You can see there's no real pattern, a lot of scatter, and so it means that this line probably is a good estimator of all these points. Okay, now let's do it again. Doing this by hand, okay, doing all of this by hand was a little bit of a pain, and if you had more than 7 points, you sure as heck wouldn't want to do that. So this is where we left off. Okay, let's do it again, but with different data and only use a calculator. So you should have in class taken the time to carefully graph these x and y points, which I did here. Okay, now we're going to use our calculator, and this is just one more review on. I've listed my data in list 1 and list 2. Stat, calculate, number 8. Now this is the old school version, but remember we wanted our data in list 1 and our y data in list 2. And then if you want to save it, you go vars, y vars, function y1. Okay, and there it is. Now why do I now have r and r squared? It would be because I didn't turn on my diagnostics. So again, here's a quick review. Go to catalog, hit D or E. E is sometimes closer. Diagnostics on. Now if I run it again, stat, calculate, number 8. My x is in list 1. My y is in list 2. And I want to store it so I don't have to handwrite it in. Function y1. There's all my data. Make sure you go ahead and write that down. Okay, and you need to know how to do that by yourself. All right, so if I were to go and graph this now, I'm going to go into my stat plot first and make sure all my points are on. Okay, I want it to graph list 1 and list 2. Notice that it's up here. There's my line. If I want a better picture, I can go to zoom 9. Okay, it looks like a pretty decent fit. The question is it actually a good fit? So we want to find the residuals. We want to take every y value and minus the line of best fit y value. Before we do that, let's go ahead and graph our y value. Notice, I'm going to clear this off right here, that if I want to draw it, I know my y-intercept is negative 0.243, so I'm going to go there. And that's actually hard to do on this graph. That was stupid of me. So negative 1, negative 2 in a little bit. Okay. And then I want to know where it's at 7. So I could just plug it directly into my equation, like I did right here. Or I could use the calculator. If I use the calculator, I would go second, trace, value, and I want to know the value at 7. And it's 8.92. Notice when I did it by hand, it was 8.91. Either way, it doesn't matter, so it's 7. I'm going to go over to 8.92, right about there. Okay, now, the fact that I had to estimate this point down here, I'm going to try it again. Second, calculate a value, and see what it would be at at 1. We know what it is at 0. At 1, it's 0.8. So at 1, I'm going to go to 0.8. Okay. So, really? Oh, negative 0.8, much better. The reason I could tell that wasn't right is it wouldn't connect if I had done, that wouldn't have connected. So it's negative 0.8, which makes much more sense. Right about here. And now I can draw in my line of best fit. Okay. All right, so now using the line of best fit, we're able to get the residuals. So if we want if we were to think about it, we plugged in a 7. My y hat value would have been 8.91 or 92 based off of the calculator. And then we could subtract 9.9 minus 8.92. Nobody wants to do that by hand. So instead, okay, here's all the residuals. And let me show you, oh, I hid them with my calculator, very good, they're right here. Let me show you how I would get that. It only works if you've already made your line, not necessarily graphed it, but ran stat calculate number 8. Otherwise it doesn't work. Now we're going to go back into our stat edit, okay, and we're going to go to list 3, push up here. And if we go into second stat, there's our list. This resid here will not show up if you haven't made a line of best fit. But if you pick number 7, that's our residuals, and it's going to give us all of our residuals. Press enter, and there they are. Okay, so it really is, the calculator just did everything we did here by hand and gave us this list for this data. So write that in for yourself. And the reason we care is we can now quickly graph it. So you may want to pause and graph it, but I have graphed every point. Looking at that point, does it appear to be a pattern? And for me, I would say, yeah, it's almost a U shape, which means maybe a curved regression line would have been better. Okay, and if you look very, very carefully at this, it is very slightly curved. So even though we have a very high R value, which is saying that the points do fit the line nicely, they would have fit a curved line even better. And that's why the residuals are so important. Because yes, if your scatter plot looks like this, very obvious that a straight line's not going to fit. But in this case, it's kind of hard to tell. Okay? It's kind of hard to tell that these red points here don't fit that pink line. So the residual helps us. All right. And if you wanted to see a graph of this, you'd go to second stat plot. Because again, you don't have to do it by hand. And change this to list 3. We want our regular x's, but we want our differences here. And we're going to zoom 9. And there we go. You can see how it looks. Pretty U-shaped, which means this would have probably done much better with a curved line of best fit. All right, so let's see what's next. Here is my instructions for that. Then you put your data into list 1, your x is list 1, your y is in list 2, and your residuals in list 3. Okay, and this is a typo. The scatter plot should be L1, L3. There's a harder way to do it where you would need to use L4. Okay, so again, for the second data set, the data is close to the line, not much scatter, high correlation, even though there's an obvious curve in the residual plot. The residual plot indicates that a line is not the best way to model this data. However, the lack of scatter means that although the predictions using the linear model linear model will be pretty accurate, but not as accurate as curved data. In conclusion, a residual plot will tell you if a linear model is the right type of model, i.e. has the right form, or if we should consider using a nonlinear model. They do have nonlinear models. You won't need to work with them. The correlation coefficient, however, tells us how much scatter there is from the line of best fit, regardless, I can't say this enough, of whether or not it's the best model. Note, sometimes the residual plot is made in a different way, where the y hat values go on the x-axis and the residuals on the y, and that's just different computer package software. Here's my little joke about extrapolation. Okay, as you can see, by late next month you will have over 4 dozen husbands. Better get a bulk rate on wedding cake. Well, this was only 2 points. Okay, so yes, from yesterday to today they had a direct correlation of getting married. She picked up a husband, but she's not going to keep picking up husbands, right? The domain is different, so it's just kind of funny. All right, question 2. How accurate will our predictions be? And I'm going to pause here and make this on a next video.